Good afternoon. It's a pleasure to take part in this virtual pitch day. This topic in particular has a special significance for me as my last job in the private sector was as the CEO of an AI startup company. Artificial intelligence technologies are transforming our economy and our society. I am sure that I'm preaching to the choir here when I say that they must also transform our approach to defense. As industry experts, you're well aware that AI is not a single technology, nor does impact just one part of the defense enterprise. The term AI encompasses learning algorithms that have existed for decades in some cases, but they are only now showing their true promise due to other advances in microelectronics, for example, as well as new techniques and methodologies that are emerging from our universities and our startups every single day. AI applications span the health, transportation, manufacturing, and information industries, just to name a few. Within these industries, AI touches planning and scheduling, natural language processing, image recognition, and also controls a growing class of hardware systems. In short, AI is everywhere and it is only growing. So it's difficult to talk in concrete terms about the future of AI. And it has been said that it's hard to make predictions, especially about the future. This is certainly the case when we're referring to a subject as broad and as deep as AI is today. However, the focus of this Speech Day event is more focused than AI in all of its possible incarnations. Today, we're interested in exploring proposals related to trusted AI at scale. So that then means there are three pieces of this puzzle to unpack. The AI piece is the broadest in some sense and the most talked about. Now, in a conference like this, I think we all understand what we mean by AI. So, this leaves trusted and at scale. So I want to focus my remarks on these last two topics. The first of these, trust, is probably the most important. Whether it's self-driving cars, autonomous surgical equipment, or weapons carrying drones. Trust in the AI tools that we are partnered with is essential to success. Regardless of their capability, if our tools are not trusted, they will not be used. Now, it's often been said, and I think we experience that in our daily life, trust is a two-way street. While it may not appear obvious on the surface, this is certainly the case for human-machine teaming as much as it is for human-human teaming. Trust requires more than a belief in a teammate's capabilities. It requires a deep and instinctive understanding of what that teammate will do in a given situation. Thankfully, this need not mean a deep and thorough technical understanding of the development and inner operating conditions of one's partner. Just as two basketball players cannot peer into the neurological processes in each other's brains, an AI and its human teammate will be equally incapable of fully understanding the neuron level activity that leads to an action in their partner. What is required is a shared model of the world and their place in it. So just as a sports team must practice together to play together, so AI development must go hand in hand with the end user. Quarterly reviews over slide decks in the conference room really are not sufficient. The operator and the AI agent must be trained together in environments that are similar enough to their final operating conditions so that problems are identified early and adjustments are made continuously. In some cases, this may involve adjustments on the part of the AI. In others, we may be forced to tackle the harder challenge of adjusting the manner in which the human operator completes his or her part of the mission. In the end, we can only succeed when the human and the AI share a mental model of what the other will do next, given the operating conditions. While expert humans and expert machines excel in isolation, the true potential of both can only be realized when they're brought together as teammates that understand each other's strengths and weaknesses. This is a lesson that we have learned again and again in related disciplines. So, for example, in In medicine, cancer spotting AI agents quickly exceeded human radiologists' capability to find tumors. The doctors, however, made very poor use of the tools until they were adjusted to provide recommendations that doctors could interpret and understand. The result was an AI that was slightly less accurate in detecting cancer, but a human machine team that was much better than the best of either in isolation. In another example, research has shown that local meteorologists, I apologize, this is a difficult word for me to pronounce, remain more accurate in their forecasts than leading edge algorithms are. Long exposure to both the local conditions and the daily experience with the successes and failures of weather prediction software allows these individuals to take the algorithm's output and improve upon it. It's this sort of AI that we must pursue. So a trusted AI application need not mean that it is always right, nor that the operator always believes what it is telling them. It means that the operator and the AI share a common framework through which each one of them can improve upon the best efforts of the other. It means that when one is wrong, the other is able to recognize and predict the mistake rather than blindly act upon it. To do this, we must bring the two together as early and as often as possible. So as you move ahead with your programs and seek to develop the wonderful game-changing capabilities that you're being funded for, let this be your mantra. Build a little, test a little, field a little. If we do this, we will not go far wrong. Now, the second piece of the puzzle to unpack is at scale. Just as trust must be understood in the context of how the operator will use the application, at scale must be understood in the context in which the application will be ultimately deployed. The Department of Defense deploys over 2 million people across every continent on Earth and occasionally above it. At scale for such an enterprise can be a truly daunting thing to consider. However, just as a trusted AI agent need not always be right, so an application successfully deployed at scale need not always mean across the entire enterprise. AI solutions, therefore, are successful not when they reach a predefined level of reach or number of users, but when they can be deployed in all of the environments and in all of the conditions for which they were designed. For some applications, this may mean working across a single formation of aircraft or in a single operating center. For others, it might mean that the tools you have developed can be accessed by any airman or guardian anywhere in the world. Success for others will mean that their applications must be able to run on very low power or in very small systems. For yet others, success may mean the ability to utilize tens of thousands of nodes in a vastly distributed high-performance computing network. In others, we may need the applications to be robust enough to be able to operate in environments where communication is repeatedly lost or information that we get from the sensors is only intermittent. So what scale means to you may not mean the same thing that it does to the pitch before yours or the one after. We should embrace this diversity and focus on developing the technologies that are needed to ensure that our AI-driven applications can be deployed where they are most needed and operate most effectively where they can do the greatest good. So rather than forcing our systems into an artificial one-size-fits-all approach, we must learn how to tie different systems together. Instead of weaving a detailed tapestry from a master plan decades in the making, we must enable ourselves to rapidly build multiple mosaics out of the tiles that we have on hand. At scale is therefore less of a focus on size and reach and more a judgment about flexibility and use across a wide variety of operators and operating conditions. Systems that scale are systems that work well with many different partners and can be rapidly recombined when the operating picture changes. So as you look toward the technologies of the future, take a moment to consider not only how your research and development will fit into the existing picture, but how it can be made to fit into a future picture that has not yet been planned for. By working together to build systems with this capability, we'll ensure the resilience of the defense enterprise regardless of the future threat. This will enable us to move beyond the threats of today and tomorrow and truly begin to build enduring capabilities that scale to whatever challenges we face in the unpredictable years to come. So let me leave you with those two charges as you consider the meaning of trusted AI at scale. To develop trust, include the operator at every stage. Build a little, test a little, field a little. To develop AI that will scale to the needs of the department and into the future, build a system that is modular and flexible, a system that can be rapidly assembled with partners like a mosaic, rather than one that relies on a fixed pattern like a tapestry. Finally, I want to thank you again for the opportunity to join in this exciting venture, and I wish you all the very best as you move ahead in developing the capabilities of tomorrow. Thank you.